Welcome to Tech Transforms. I'm your host, Carolyn Ford, and today I'm joined by Dr. Will Roper, one of the architects of defense digital transformation. From leading the Air Force's move to the cloud during COVID to launching swarms of micro drones, I'm not kidding. Dr. Roper doesn't just talk innovation, he builds it. Now, as CEO of Astari Digital, he's asking, what if AI can't scale because the internet was never designed to support it? Welcome to Tech Transforms, Dr. Roper.
Thanks so much, Carolyn. You are welcome to call me Will during the podcast. I've been out of government service for quite a few years, and I enjoy the world of tech where everyone's on a first name basis.
I love that. And it's like Will Stryker from Star Trek. So there we go.
My wife's
um,
a huge Star Trek fan, so she would love that.
there you go. Well, let's just start with what if AI can't scale because the internet was never designed to support it? I'm not going to lie. I was thinking about what we were going to talk about, and that statement of yours, I haven't heard it and before now, and I thought, wow, why have I not heard it before now? So talk to me about what's broken and what your proposed fix is.
It wasn't obvious to me either, Carolyn. I've had a front row seat on bringing new technology into the world of aerospace and defense. And like any good problem, you see it clearly when you look back on it. You never really see it clearly when you're facing it. So to give your viewers a little bit of backdrop, like I was there. I was the creator of Project Maven when I worked for the Secretary of
Mm,
Defense, which was the first AI program
yep.
for the entire defense. And I still remember having to put together a decision brief for Secretary Bob Work explaining why this machine learning business was different than all the other automatic target recognition programs of the 70s, 80s, and 90s, why we were not going to throw good money after bad chasing this. And
Hmm.
thankfully, I was able to convince Bob that this was really something different and we should do it. And Maven ended up growing up into something far bigger than my original Pathfinder, but most people know it because of what ended up happening with the Performer. But the real story of Maven is that it showed me that the military was not ready for the internet, much less AI. I was running around with Eric Schmidt. We didn't have a cloud. We didn't have any development environments. We didn't even know who could code for us in the Department of Defense. And so when I moved over and joined the Air Force and later Space Force as the acquisition executive, I took those lessons to heart and said, we got to build the internet. So we needed to adopt a cloud. We needed to adopt a development platform so we could write code for our missions. We needed to know who could code within our ranks, and we needed to know who was a good coder outside in industry. All of these were things that we had to do before we could even attempt AI. And at the very end of my government service, we finally put the first artificial intelligence on a military jet, the U-2 spy plane, and let it have control. So that gets the headline, but what the real work was behind the scenes was just building the infrastructure. And that has been the theme for me since leaving government service is that the infrastructure that I needed in defense simply isn't there to do just software for cyber physical systems, much less AI. And so that's what I mean by the internet was not meant for an industry that's highly regulated, that's highly fragmented. But it could be if there was a different kind of infrastructure that didn't want you to consolidate all of your data together to get efficiencies. That's amazing for us as individuals. It's amazing for many industries that can accept centralization. But most industries can't. Everyone owns their IP. Governments have levels of classification. You are not going to bring that stuff together. And a bureaucracy, which often is a pejorative, is there for a reason. It's checks and balances, it's separation of authority. And so as you look at the internet, what makes it great, if you put your data in a cloud, you have access to it everywhere. You have analytics and AI running there that you could never have running locally. It makes our lives powerful. But the second you need it to break up and federate, the internet doesn't have any solutions for you. And of course, that's equally true if you want to break it up and do AI between the different data sources. Well, that is the aerospace problem. That's the problem I wanted to be able to solve when I was in government service, and the tech just wasn't there. And it took me about half a year after leaving government service to look backwards on the problem and finally see it for what it is. It
Hmm.
wasn't an issue with us per se. It was an issue with the infrastructure that we had, and that was the problem to go fix.
How long have you been in private sector?
So I was in government service for 10, almost. I'm getting close to 5 years, 4.5 now out. And so it's, I did a little bit of advising in the last administration on the Defense Innovation Board. So I did have an official role and kept base, but it's very different advising versus doing. But I've
Hmm.
really enjoyed being on the outside because when you're in the Pentagon every day, you get further and further away from currency and
Mm.
technology. So if I ever do end up back in, which no one's offering a gig at any time in the near future, I'll at least feel like I'm current again, like I
Hmm.
was when I worked for Secretary Carter when he was the Secretary of Defense.
What you're saying about the internet, like I feel like it sounds like it needs to be retrofitted. Is that even possible? I mean, the internet, I- for lack of a better analogy, like it's a virus. It's out. It's done.
Mhm.
So it reminds me of I've heard you I've seen you use the phrase sovereign data territories when you say um, federalize and break it up. Is that what you're talking about? And I mean, how do you do this to this vast new world that's been around now for 25 years?
I'm going to answer the question, but I want to own up front. For a long time, I had no idea what the answer was. All I
Hmm.
knew when I was in government service and then transitioned out, that there were two different worlds living alongside each other. And I lived this when I was in federal service. I would wake up each morning, and in my personal life, I was powerful. I was connected to everything. I could check on my
Mm.
finances. I could crank
Hmm.
my car without going outside. Everything was connected. And then I would go into my public service life and I would be connected to almost nothing, running, $60 billion a year and over 5,000 airplanes and satellites. But yet I didn't feel as powerful from a connection standpoint as I did just sitting at home. These two different worlds lived alongside each other. Now, why did they do that? Well, at home, I'm one of those. I've clicked the I agree button because I want the convenience of the internet, and most people have.
That's
I
right.
think we realize deep down that our individual data, though we don't want it in the hands of people we wouldn't choose to have it, that it's not that valuable on its own, right?
Hmm.
My
Hmm.
personal choices, the what I'm streaming on Netflix is not valuable. But if we aggregate it together with everyone else's, it does become valuable. And
Hmm.
we get the benefit of that in terms of convenience. So we've all accepted that. That's the personal internet. And there's nothing wrong with it. Like it's made our lives amazingly efficient. It's birthed AI as we know it, all of the models that are now re-evolving how we live. It's amazing. Now, contrast that with my public service life, which really resembles any industry that has any kind of regulation or IP. They're not clicking, I agree. They can't, right? That's
That's
their
right.
advantage. Their data is valuable. So what do they do with it? They firewall it away because they need to
Hmm.
protect it. And if they need others to use it, they'll put an army of lawyers between the user and the owner of the data to ensure it's not misused. That's my government experience.
Yeah.
That's being on the internet, but like not of it, right?
Okay.
You're not participating. So what a sovereign data territory is, and we'll come up with a better name for it eventually, is that firewall data isn't going to leave its firewall via an click I agree by a corporate lawyer. There needs to be a new kind of infrastructure that lets the owner protect it as if it's their own territory, their house, their rules,
Mm-hmm.
but that allows it to connect with others as they see fit. And that's not the way that any infrastructure works today. Cloud is great. We share computers. All of our data is together. It's in big server farms. We can access it everywhere. But you don't get to choose how it connects in that cloud to a high degree, and you certainly don't get to choose how it connects outside of that cloud. And so the infrastructure that we created in Astari Digital is to do that. It's not to give you a better compute environment to run in. It's to let everyone choose their existing environment, choose their existing firewalls, choose their existing authentication means, whatever it is that makes that owner of data feel like it is properly protected. Don't touch it because you're
Mm-hmm.
you're trying to run up a vertical wall. Don't touch it. Live behind it and allow that owner to selectively choose how to connect it. Now, that sounds easy. It's really hard to do, but that is the gateway I needed to opening up software processes for aerospace, for bureaucracy itself, and then, of course, opening up the gates for AI. It's so
Mm.
clear looking back, but it was not looking forward. Like any good problem, as you grapple with it, you start to understand it better and better.
So the way my brain is thinking about this is, the nation of Carolyn, my digital nation, is maybe even like Kubernetes. Like I have my container, I can get what I want, but nobody can get in unless I let them in. Are we talking about that?
It's exactly right. Containers were like, I think about that a lot, Carolyn, because that was like saved my life. Not
Hmm.
literally, but in the Air Force and Space Force, I was the first adopter of cloud and defense. This was back when Jedi was going on. I realized when containers came out that we could hybridize cloud, and we did, but it was more than that. We could move code from the cloud to the jet, and it was just seamless. The
Hmm.
B-2 bomber at the time was overrunning. We had no idea why the code would not run on the jet, and then containers came out and the problem just vanished.
Are the
What
containers really secure? Like you can take this section off this piece of stuff that you want and put it in your jet from the cloud. See, I'm not a developer. I'm not technical, so.
Well, I mean, and with the team I work with now, neither am I. What containers did, it's not the same as what we do in a story, but it's really instructive. It's a great example to talk about and insightful of you to bring it up. It's containers took what I didn't dare to think at the time, that the problem was software itself. I
Mm,
thought the problem was our jet or our cloud and the fact that they would not work together. I
mm,
didn't look at software and say the problem is a core software function. It took Google to realize that no, we needed to change the way that software could be run so that it ran the same way regardless of the computer that it's on. That sounds so obvious looking back,
mm.
but it wasn't. Like we were in the VM, virtual machine
Yeah.
era. It was not the way. Well, Google saw that. They eventually open sourced it. It's changed the world, changed the Internet of Things into an Internet of Code. It's amazing.
And we
Well,
saw it happen on the U2, right? I'm going back to
exactly.
your paper of 5 years ago, and I'm remembering, right? Like we proved this time and time again. This can really be done.
It was a big moment for the Air Force. Like, like we got that if we validated the technology, we did not have to validate every single piece of code we needed to move.
Yeah.
Containerization is an example of Google embraced the complexity of deploying code and created a technology uniquely for it.
Mm,
The problem of sharing data is different than the problem of sharing code. We don't want to move the data around like containers help solve for deploying software.
hmm.
Instead, we want to change the paradigm for how easy it is to connect data, to have people think, I didn't actually think the problem was the way in which we share data. Like it's data itself that is the problem, not the fact that my systems aren't compatible or that I work at a different level of classification. That's the paradigm shift that our customers are undergoing. It's a 180. It just makes problems go away that they never considered weren't the real problem in front of them if you embrace the complexity in a new tech. And it's been a long time since a new infrastructure has come out. I mean, I think containers are arguably the last one that was an infrastructure as code. And
Mm.
I think Astari is bringing out the next new one. And although we're just getting started, I expect that we're going to find that same, like, you can do anything with it response. And it's fun seeing what customers are already doing.
I want to talk about your paper that you wrote about 5 years ago, There Is No Spoon. I told you it's a new discovery of mine, so I'm super excited about it. So all of our listeners that have read it, you're just gonna have to be patient with me while I geek out on it because it's a brilliant paper. I told you before we started, I'm not in the military, I'm not in public service, I don't build planes, and this paper resonated with me. So listeners, if you haven't read it, go find it. It's worth the read. Going back to your There Is No Spoon paper, are we going to 2.0 with Astari? Is that what's happening?
We are. I wrote There Is No Spoon that my lovely wife allowed me to write it over the vacation we took during COVID. I sat on the beach and typed it out. And it started a bit as a joke for me, where I was having a bit of fun. I was on vacation, but there was a little bit of method in the madness. I had just gotten exposed to Formula One racing. I wasn't very familiar with the sport, but McLaren Racing was kind enough to show me how they built race cars. And it was like watching software developers, but they were developing real race cars, over
Mm.
1,000 for every race. There was no aerospace program that could even attempt that. And the races are just a few weeks apart. So they're building 1,000 different digital twins and they have to do it. It's not like doing it for style points. If they don't design that number, they don't have a really good match to the actual race day conditions. They design for temperature and humidity, driver
Mm-hmm.
field. They even model the pit crews and their ergonomics so that they can
Mm.
predict like down to the millisecond how long things will take. It was
Well,
like
and I
stepping.
know that they outfit those cars because I have a friend who's really into Formula One racing, and they outfit those cars with like thousands of sensors too. So that data is getting fed back to these digital models, like on the tires and everywhere. There's all these sensors.
It's exactly like at least at that time, 5 years ago, it was 300 gigabytes per race being streamed back.
Oh
The
my
the
gosh.
the engineers are at the race, but they're not watching it. They're watching their screens and they're trying to simulate the race faster than it's happening to change the strategies. The race car in its physical form and its digital form are truly tethered together. They're one
Mm.
organism. It was like watching a science fiction film. And of
Well,
course, I was
it's like they're
inspired.
watching the Matrix. You've got your engineers watching the Matrix, and you're
It
driving.
was.
I love it.
And I'm a big science fiction fan, always have been. I originally did not start with that. I told our Air Force executives like this is a big deal. Like they're building software like code, and the response I got was, hey Will, we're building everything with computers. We are digitally engineering, but it wasn't like this. And so I took the time to write it and tried to make it a little entertaining, but also have some insights so that people would realize at a minimum, I believed what I said. I thought this was a big deal and it was worth the time to read. And if you go through the paper, there are three different tenets that it seemed to me were things we would need to copy Formula One. I'll go ahead and do the last two because it's the first one that looking back, it did not have a technical solution. So
Mm.
one was we needed to be able to get from the development environment to the edge very quickly. Formula One
Mm-hmm.
could, right?
Mm-hmm.
They're actually one organism at the race day. I would have been happy with deploying quickly. Well, containers were breaking down that barrier. So warping from your tech stack to the edge, check. The third principle was pivoting to digital first operations, like creating before you aviate, just to make it catchy and
So
memorable.
really living in the simulation is what you're
It-
talking about. And are we
That's
really that good? Well, I mean,
Formula One.
Formula One is.
Formula One is. It's realer than the race. In a sense, the race they car is almost like a printed document. I mean, do you think like a paper document? Do you think that's the real document anymore? Or do you feel like I really want that e-document where I can manipulate it and send it everywhere? I can sign it. I can
Mm.
we've flipped polarity on the way that we correspond. Formula One's flipped polarity on
Oh
physical
my
race
gosh.
cars.
The car is the printed document. It's not the
Yep.
real thing. Oh, it's just blowing my mind. Okay.
Because you can't change it anymore, right?
Yeah.
The power is in the change, it's in the feedback. You have to print it because that's what a race is. You can only have one car. But for their process, if you step back from it, the car is going to change 85% over the entire season. That first car is not there anymore. So they're not winning with race cars, they're winning with a race car process that
So
prints
do they
32
print a new
times.
car like literally after they race?
Everything changes about every 15 minutes. Something has been redesigned and recertified. The car is never static. It is a
Oh,
truly living, evolving process, just like code on the internet today is
yeah.
never static.
But how do they build it that fast? Like, are they using 3D printers? How are they like physically building it?
And that takes us to the first principle of there is no spoon. That did not have it had a solution for Formula One, did not have one for us in aerospace.
Mm,
And that is that they own a shared development environment or tech stack.
hmm
When you work with Formula One, and I do today, Formula One has one environment that has all of their models and simulations that represent their cars. They have really good engineers, but they're all using the same environment and it's all connected together. So they can go from a requirements change and then go all the way through the design, through the simulation, even check to make sure that it's going to meet regulations and be safe. That can run as a software process. So they have the ability to own a shared tech stack amongst their entire supplier base, which is mostly them.
hmm
We did not in aerospace. That is where we hit the wall, is that we have thousands of suppliers for a weapons system. We have
Right.
lots of classification. The only programs that we could copy Formula One were ones that were so classified that we brought all of the data together for national security reasons. And those programs did see some of the same results. F-47, now that's being talked about in public, was one of the ones that was really promising to me on my watch. But they were the exceptions. They weren't the rule. There wasn't an infrastructure that embraced what Formula One did centrally, decentrally. That's
Mm,
the thing that we had to solve in Astari is how do we break it up? How do we get all of that benefit of connection
hmm
without the detriment of consolidation? And if you can solve that one thing, so easy to say, so hard to do. We
Yeah, I
want to
mean, how do
con
you secure it? Like that sounds, I'm just like, whoa, whoa, hold back.
it's
There's a
hard.
security issue.
Yeah, I mean, if you consolidate, you're going to inherit the baggage of all security concerns.
Mm,
But if you can make the connection have no security, zero sensitivity, separate from the data itself, now you've got a solution. You got one that I would have adopted, and here's
are
why.
you air gapping it? Like, how are you doing that?
This is there's always a clever trick for any problem. So the data is sensitive. Take a
hmm
military aircraft. It's at
hmm
lots of levels of classification. There's no technology changing that. IP is sensitive.
mm,
Data is AI is even more sensitive now. Most
hmm
valuable
hmm
IP in existence. You're not changing that. The connections between things rarely are. I'll give you an example. let's say you and I are building a super classified airplane. I am building the fuselage. You are building the wings.
Hmm.
And our designs are top secret. Can't share them with anyone. You and I have to periodically check in to make sure that our two systems will integrate together. Else, you're going to build a wing that doesn't strap onto my fuselage and an airplane it does not make. And so you and I will have a set of documents that will define how our two systems are supposed to mate together. It's going to be
Mm.
things like separations of bolts and strengths
Hmm.
of things and
Right.
material.
We still don't have to see each other's stuff. We just need
Ex-
to know, right. So is this part of like your, I was going to say using bureaucracy as code, but that's taking us down a different path. So keep going.
it is what we're doing on the X plane we're building with Skunkworks is if you think of that document, it's not a document. Imagine just kind of, go into the future matrix. It's not a document anymore. What if it was a set of software tests that you could
Hmm.
run? Like are do the holes and bolts align? You can check this for almost any circumstance you can think about. That's not sensitive. Like the
Right.
fact that your wing will fit my fuselage, it doesn't tell you anything. There might be a rare exception, but I've seen very few. That
Hmm.
allows us to create a connection layer, which is checking integration, which has almost no sensitivity, which
Hmm.
is separate from the very sensitive data, which is our design. You and I could check integration via a software process every second of every day without having to bring our data together if there's a way to do that check that works both ways, meaning neither of us can have the high ground. We
Hmm.
have to be on a level playing field, a level digital playing field. That means that if I can check it, you can check it. And if we can both do that, that makes it a peer-to-peer protocol, kind of like encryption on the internet when we do e-commerce is a math protocol. In theory, anyone can check it. It doesn't favor the seller or the buyer. It's a level digital playing field. It's fair. The Starry's protocol is the same way. It's a math protocol that can be checked by both parties. That
Hmm.
puts them on the same level playing field, which means you don't have to trust anyone. You can verify everything. And the
Hmm.
fact that you can verify everything means that you can extend a zero trust architecture where you don't trust
Right.
anything, you verify. You can now extend it across collaboration. Now we're ready to do Formula One. That's the trick, is to make the connection layer something that can be shared because it's not sensitive and
Mm.
validated by both parties on both ends, like RSA encryption today. Now we're ready to do what the world of software does, but break it up across the different authorities and data sources.
I mean, I love it. It sounds like, duh, of course, this is what we should do. And I have no idea how it's even remotely possible. Like, it kind of like when I start thinking about, okay, logistically, how's this going to happen? Because Formula One, they don't have to just have the connection points. They share everything, right? Like, they're not trying to keep the parts separate and secret. They just share it all. So now so this problem that Istari is tackling is just monumental and definitely a paradigm shift.
Formula One consolidation isn't a barrier. Like they own most of their IP, and the IP they don't
Mm,
own, they're in exclusive relationships. There's no big deal
right.
putting
They
the
don't
tire.
care.
Yeah, it's
Yeah, it's not national
all
security. Yeah,
yeah.
I got
You
it.
know, so for most industries, it's the lawyers who say can't do that. The same ones who'll say can't click I agree. So we designed for the lawyers so that they'll be the ones who are the happiest of anyone because this is more secure than things have ever been. And we put this into play because you got to teach people through doing. I learned that in government service. Like you
Hmm.
can't just have theory. So when I decided to start bringing this out, we started a program with the Air Force, And Lockheed Martin Skunk Works, who's our subcontractor, they've never subbed to a startup. So it's been fun all around seeing how this would go. But Skunk Works has built some of the most famous airplanes in history. The SR-71, the U-2,
Mhm.
F-117. I mean, it's got a fabled history. Well, we wanted to do something that's also a first of its kind with them, which is the first airplane that's digitally certified, meaning none of that paper exchanges where the two
You're
different
gonna certify it before you actually build it?
we're going to do that.
I gotta
But you know
stop
that
using that word though, because you're building it.
we are building. You need
It's
to
just
do
not in
that.
the physical world yet.
Well, you design it.
Yeah.
You can certification I view as like it's a knob, not a switch. That's what the
Hmm.
program is doing. That is thing one. And thing two, it's trying to make certification something that can run continuously the way the software world does. That's what Toyota did with the Andon cord is they made quality something that happens all along a production line. They made it a continuous process before
Hmm.
the world of software even existed. We just want to do that with airworthiness. And the way it
Hmm.
works is Lockheed Martin is the designer of the X-plane. So they're the source of truth, right? No one else is. They're the ones making it. Normally, they would have to take all of the different details in their models and sims and 100 other tools and put them in a human readable document for airworthiness and certification experts to read to parse criteria and say, I feel good about this one, not good about another. That goes back and forth, sometimes for years before
Hmm.
certification's granted.
Hmm.
This X plane is the first where there is no paper in between. Lockheed's sources of truth can run directly against the Air Force's. And like we were talking about, both are on a level digital playing field. They both get to see the pass fail tests that are run between the two systems. They're not sensitive. They're not owned by anyone. They're
Hmm.
criteria between two things. And although we'll show that it is possible to grant a certification based on digital mechanisms, what's even bigger about the program is what we'll do next year because we're building the physical asset. Because if you don't, people are always going to wonder if it was like a stunt or something. It's not
Right.
for Formula
Right.
One.
You can
So
build
we're
anything on a slide. Like
yeah,
you
as
can do
long as you yeah
slideware till, yeah,
yeah as long as you don't have as long as you're not responsible, then of
that's
course it's good.
right.
But we're creating what we call a digital flight envelope. And this doesn't exist. This is a term we're making up. A digital flight envelope's like a flight envelope that an airplane has. A flight envelope is all the conditions the airplane can fly safely. When you reach the edge of the envelope, you're right
Hmm.
at the stall point. If you go a little further, you fall.
Hmm.
So we've created the digital flight envelope, which is what the models and sims think that flight envelope is. It's intentionally conservative, a little conservative than what we think reality is. There is a real physical flight envelope that is not known. It won't be known until the physical airplane flies and measures itself, just like those Formula One cars. When this airplane gets to fly for the first time, there will be these test points where the digital and the physical need to overlap. So the
Hmm.
airplane will have a sensor measurement and then there'll be a prediction from the models. The difference between them will be calculated. And if it's small enough within acceptable bounds to the Air Force, then we pass and you get to fly to the next point. The airplane will literally certify itself as it flies. And it won't just do it once, it'll do it all the time. It's like a software process
Hmm.
in the air. Now, I think that's going to end up being revolutionary, more so than whether you can certify prior to making, because imagine in future having airplanes and anything in the physical world continually evaluate and recertify itself. It
Right.
could change everything about safety. So this is the first time this has been attempted. Failure is an option. It always is when you do something new, but I think it's going to work. And I think it's going to set a precedent that goes far beyond the life of the X plane it's flying on.
I would imagine when Formula One first started doing this, how long ago was that? Are we talking like 2015? Are we a decade now they've been doing this or
Yeah, I
less?
think I mean, Formula One's constantly evolving, and so
Hmm.
I'd say 8 years ago really
Okay.
begins the beginning of the digital era. Certainly 5 years ago, it was in full force, and
Hmm.
now they're not just cost capped, which is what drove the digital boom. They're
Yeah.
compute capped because they continue to push innovation. It's an amazing industry that just you give them a boundary, you create a new generation of innovation.
Is it the right term to call the real the real car that's the code? Is it the digital twin? Is that the right term?
I think it's the term I think will stick. I think it's been a term that's held back digital transformation because
Mm,
it does make you think of the Matrix and like this thing needs to be picture perfect visually. A digital twin could be like a simple lookup table, like a mathematical curve where you look up a
hmm.
number. If it's good enough for reality and you're willing to make a decision based on it, it's a digital twin. Digital twin for me means actionable. I'm willing to take real world actions. I
Mm,
don't need to independently validate that. If I do, it could be useful information, but it's still not a surrogate for reality. Formula One, they're surrogates. They're making
hmm.
real world decisions all the time. And aerospace will get there very soon, I think.
When Formula One first started doing this, then, so we're talking within the decade, do you know if what looked like the digital twin was like perfect, and then when they built the physical thing, if the physical thing just like the wheels came off when they first started doing it?
It wasn't quite that like that. But in 2022, I believe there were some changes in the regulations all the time, and there were changes that allow different structures underneath the car. A Formula One car is like an upside down airplane. It's a wing design
Hmm.
sucking itself into the ground so it can go faster. Well, they changed the regulations to allow some new undercarriage wing designs, and of course, all the teams wanted to take advantage of it. And they all knew that because they had never actually raced these cars, they can't just go out and test all they want in the physical world because they're cost capped. So
Hmm.
they had to kind of wait until it's right at track time. They all had a pretty similar problem that was this porpoising problem. Like the car would go up and down. It
Mm,
wouldn't suck itself down in a good way. And the
hmm.
teams that ended up, it wasn't being right up front. That's like the DoD bureaucracy's way of trying to get things right. Like we're gonna think about it long enough. We'll absolutely have it right with our initial plan.
And then we won't need it anymore because it'll be that long that yeah.
It's crazy in the world of tech to think about your initial plan being completely right. But the teams knew they wouldn't be. And so they were all fighting for cycle time to try to collect the data from the track, from the real race,
Hmm.
update their models and sims so they could update their cars and get rid of the porpoising effect. Teams like Red Bull were able to do that and they were able to win the season. Teams like Mercedes that had just brought on their W13 car, a new car design they had a lot of hope for. It took them about half the season to find it. And their tech director said it boiled down to a single error. Once they found that, the car corrected, and they ended up winning one Grand Prix. So it wasn't a complete loss for them that season, but a lot of disappointment compared to what they hoped for. It's the way digital twins should be thought of. They're not right. They're
Right.
evolving to closer and closer approximations of reality, and
Hmm.
reality itself is evolving. These are
Hmm.
processes. These are not fixed states, but they're more they have the ability to be safer for us because they are chasing reality. But I think we're going to find, just like Formula One does, that in the pursuit of being safer, they are so much faster than the way we do business today.
Mm. I'm going to take us to one of my favorite parts of the show, which is our tech talk questions. These are rapid fire questions. Just answer from your gut. Have fun with them. So first tech talk question is, you get to program your digital dojo. What is the one skill that you are going to choose?
I'd want to be able to fly,
Oh, yeah. Just like no airplanes, just fly.
just
Okay.
like Neo does
Neo.
in the Matrix.
Yeah.
As much as you want to try to talk around it, aerospace is a romantic industry because of aerodynamic flight and space flight, and just being able to experience that. Like I flew in the U-2 before I left government service. It's one of the most impressionable moments that I've had, seeing
Mm,
the Earth curve below. I would love when I need to feel better about the
mhm,
world and also more grateful to be able to just fly up and just see the world as it is.
I love that. Although Neo wasn't able to download that, right? That was something he had to learn, just
He
like into it.
He did, right? He did. I'm taking a
Yeah.
little license with I'm assuming I can download Neo's insights, but during the course of the movie, you start the movie thinking like that, that the Matrix is a prison, and it is. But if you think about it, it's kind of a weird turn of events. The Matrix is a level playing field, just like Astari creates for customers. Like Agent Smith knows these insights. He
Hmm.
knows how the matrix works. Gravity isn't a law of nature in the matrix. It's some setting on a drop-down menu that can be changed. And
Code.
once Neo realizes that,
Yeah.
he's on the same footing as Agent Smith and ends up eclipsing him. So I love that there are these technical things within the Matrix that hold that the level of precision is amazing, which I just
Hmm.
love. I think sci-fi often is just prescient on the future, or maybe it's that the people who love the future love sci-fi so much that we make the future like our favorite sci-fi things. But I am enjoying making the future like one of my favorite sci-fi films, which continues to be The Matrix. I think it continues to see the future in a way that's insightful.
Yeah, it's one of the greatest of all times. And one of the things that I love about The Matrix, what you just said, The Matrix is a prison until you know there is no spoon, and then it became his playground.
It
Like, how
did.
much fun did he have in The Matrix?
And then it becomes Smith's prison, right? It
Yeah,
flips. Smith is actually trapped there.
that's right.
It's, I love when things reverse around like that. But
Hmm.
I think The Matrix is a great example of what we've discussed, Carolyn, is that one of the reveals, so hopefully everyone's seen The Matrix, spoiler alerts, but yes, yeah, humanity's sleepwalking in an AI facilitated virtual reality, and they don't know it. And the reveal, as we're supposed to believe it, is that reality is actually not real and we're in a simulation, right? But we find out later that the actual reveal is that the Matrix is this balancing act that makes everyone on an equal footing, Neo and Agent Smith, because the architect of the Matrix has to own that everyone needed to have free will. He's giving everyone, to use the term we started with, their little sovereign data territory, which is in their brain. And the
Hmm.
Matrix can't play
Hmm.
with that. But what
Hmm.
is the Matrix doing? They're creating the world around those people, the world that is not sovereign free will, that's not sensitive, that can be shared. It's the roads, it's the geometry. Well, that's a little further ahead than Astari is going to get. But if you think of that the same way, every customer, every corporation ought to be like one of those people in the Matrix, except instead of being imprisoned, they're really being set free. They control their data. No one else can tell them what to do with it,
Hmm.
but they can interact and collaborate within a world they choose to share that's fair for everyone.
Right.
That I think that's kind of it's a neat thing that the Matrix ended up having this decentralization requirement. And that's exactly what I found I needed when I was in public service. I didn't need a centralized infrastructure like Formula One had. I need something new that took that power and broke it up and made it equal for everyone.
Mm. All right, if you could rewrite one law of digital physics, something hard coded into the matrix today, what would you change?
I would want all data to not be separable from its origin. I think that if that one thing could be fixed, then so many societal issues that we see right now and not knowing what is true would at least be filterable by machines.
Hmm.
And it's amazing to me that we interact with so much information every day, but most of it we can't actually prove where it came from. We have an elaborate
Mm.
system of trust
Mm-hmm.
that often works, but when it doesn't, the
Mm-hmm.
stories are heartbreaking.
Mm-hmm. All right, what's Agent Smith in our world today?
It's a step beyond this dead internet and deep fake business. It's not just deep fakes. It's not just an internet where nearly all the information is generated by machines for machines. It's just where you can never get to the bottom of anything.
Okay. So, what's the matrix moment that we're currently living through, but maybe haven't realized it?
It's the lack of technology that facilitates mutual trust.
The
And
lack of technology that facilitates mutual trust. Okay. Yeah. All right. Well, thank you so much for joining me today. This
this
is,
has been a blast. We've
oh my
covered
gosh,
a lot of topics.
I'm so energized right now. Like I said, we didn't even touch half of the questions that I had for us, but for leaders that are looking to rethink their infrastructure, where should they start?
Well, good. I mean, it's hopefully the website we have is a good place to get started at astaredigital.com. And the first thing you'll see is level digital playing field. What we hope people will see is that, no kidding, we want to put everyone on an equal footing with respect to their data and give them the power to choose how it connects.
Mm.
And for those that have, it's almost like that superpower Neo unlocks. You just never dreamed you'd ever have this level of control of your data. And then a few quick installs later, you do. And
Hmm.
that's really fun. Having been someone who needed those solutions, it's fun to provide those.
And so Istari.com is one place that people can follow you. Where else can they find you?
I'm on LinkedIn at William Roper, easy to find, and I've pretty much, I did a lot of media when I was in public service, but I also am a big believer of don't talk if there's nothing to say. And most of my career has been building technology, and technology takes about 3 years to build.
Mm.
And so I've been pretty quiet because there's nothing to say until you're done. But I think you'll see over the next few months, we have quite a bit to say. Astari has some pretty amazing stories. It has an amazing group of people. And it's time to tell the story publicly. And I just really appreciate the opportunity to share a bit more. And for all the things we didn't cover, I'd love to come back and share more at a future venue.
I would love that. I'm so glad that you were ready to have something to share today because this has been so fun. So thank you again for joining. And thank you to our listeners for tuning in. Please smash that like button and share this episode. Tech Transforms is produced by Show and Tell. Until next time, stay curious and keep imagining the future. Thanks for joining us on Tech Transforms. If you enjoyed this episode, please smash that like button and talk about it with a friend. I'm Carolyn Ford, and this is Tech Transforms.